Hello, welcome to PyRx Screencast. In this screencast, we'll go over some of the new features available in PyRx version 0.9.8. The first feature is Show Interactions tool that is available in Analyze Results tab for Autodoc and WinAWizard. To show this, I'll start PyRx. If you're new to PyRx, please see one of the earlier Getting Started screencast. I'll use this WinAWizard here. We'll later on go through the WinAWizard to show how to use this remote HPC AWS execution mode. But for now, for the interest of time, I'll jump to Analyze Results tab. Click on this plus icon. I have here already pre-computed some of the docking, and you'll find them under your home folder, .pyrex_workspace. Macromolecules and the name of your macromolecule. In this case, I have one CRN and I've docked that with histidine. So I'll open this, and this will load the histidine molecule here and the docking results in this table. You can click on this pink icon here that reads Show Interactions, and what will this do? It will select this, toggle this selection spheres icon here, and it will select all the residue, all the atoms that are in close contact with each other between ligand and macromolecules. Here we can see all the atoms in the macromolecule and the ligand that are in close contact with each other. It will also display any hydrogen bonds, if there are any, with this green line here. So this is a nice tool to quickly visualize the interaction between a ligand and macromolecule. To undo this, you can just click on this icon again, and it will deselect everything and hide the hydrogen bonds. So this was the part about the show interactions. The next new feature added to PyRx is an option to select residues inside a sphere. To use that, click on this pink sphere icon on the toolbar, and it will draw a sphere and select residues inside the sphere. You can change the dimension of the sphere by using left mouse button and dragging away from the screen. It will make the sphere smaller, or you can drag towards the screen to make the sphere larger, and it will select more residues. I'll make this very small because docking with too many flexible residues is computationally expensive and it takes too long to do the docking. But once you selected your residues, typically this is inside active site, you can right click on any of the selected residues on this molecules tab and use Autodoc flexible residues. And what this will do, it will make a flexible PDBQT file that you can use later on to do flexible residue docking with Autodoc or Winner. So we'll wait a little bit for it to finish making flexible PDBQT file, and you will find them under Autodoc tab. It will create this protein_flex, and it will create a rigid part and flexible part, and then you can use that for docking studies. You can also change the precise location of the spheres by going to TVTK tab and then click on this plus icon. Then on the render you'll find a sphere representation. If you double click on that, it will bring this widget here, and you can change the center and other parameters. So for instance, if I make this 10 exactly, I hit enter, it will move the sphere in this direction. You can also change any other number of parameters, like F1, which I suppose is Y, and that will move in Y direction, or this one here, it will move in the Z direction. So if you want precise location of the sphere, you can use this TVTK widget to change the dimension of this sphere. Last but not least, We have added an option to run virtual screening on the cloud. This is useful for the labs who don't have access to high-performance computing cluster. To use this, on the Windows Start Here page, click on this Remote HPC AWS option. It will bring this dialog and we'll need to enter key pair and the IP address of the cluster. How to set up the cluster is available on this link here. Click on that. And it will open this web page on the browser that describes how to configure and set up your cluster. And it's based on the AWS's launch on HPC on the cluster. So you can read through this article, and the first step is to create an EC2 key pair. You'll need to register for an account, and this step describes how to get your EC2 key pair. Once you get your EC2 key pair, the next step is to launch and configure your HPC cluster. Here I'll use this US West option. In this page, you'll need to provide your template for AWS's cloud formation. The template they have here by default is this for the computational fluid dynamic job. To get the Autodoc Vina to run on the AWS, you'll need to use this template here. You can right click and save it. I'll show you what's in this template. It basically sets up a way to launch the cluster. And these are the parameters you might need to change if you want to customize it. Basically, the master cluster instance type, compute cluster instance type. For computational fluid dynamic, it was C8.xlarge. For Autodoc jobs, we can use C4.xlarge. Then there is initial queue size and max queue size. You can also change these parameters here. Once you get that template, you can click on this upload template to AWS and select this template and click next. And once you've done this step, you need to do it only once. After this, AWS will save this template into your S3 bucket. To show that, I'll go here on my AWS account and find the S3 bucket. And here you'll see that I've run previously, and it has uploaded this config file here. So you just need to copy the URL of this and paste it here if you have already gone through this step. So I'll here click next. It will have it here on this page. You can name your cluster, and then you select your key pair, the master IP subnet. It doesn't matter. You can select this one. Here you specify the spot prices, so this might change depending on the cluster, on the compute instances you are using. Click next. So this is, I think, the last page where you need to you can leave everything blank and go to the next page here. And this is the last page, and it will warn that you need to acknowledge that AWS CloudFormation might create IAM instances, basically that you agree for the charges that you incur when you run this CloudFormation HPC cluster. Then you click on this create, and it will take a while to set up this. So for now, I'll just go to my EC2 instances. I have already one of the instances running that has everything that we need to run the docking. So once you created your instance, you will be able to go and find the IP address of your instance. In this case, it's EC2 instance, but when you run the AWS CloudFormation, it will be AWS CloudFormation instance. So I'll copy this and go back to PyRx. So and enter that IP address here. So again, we have key pair you get on the first step, and the IP address you get when you launch your AWS CloudFormation. Click OK. So now we are ready to set up and run the jobs on the cloud. So I'll click Start, and then you'll use this straightforward menu wizard to run virtual screening or inverse virtual screening. You can select multiple macromolecules, multiple ligands. So I'll just select a couple of ligands, and then select one of my protein and click forward. And this page you specify the search dimension, so I'll leave everything default and click forward. Now it will start submitting job to AWS cluster. So and you will see that it's queued one of the jobs. If you have many compute instances, they will be all running at once. So in this case, it will just run each job sequentially. And then once it's finished, it will download all the results and we'll be able to analyze them and go to the next page. So let's go back to the launch and HPC cluster. So you can also follow this tutorial all the way, and it will launch the computational fluid dynamic job, and to get familiar with the AWS CloudFormation in their HPC cluster. In the end, when everything is done, you need to terminate your instance. Step 5 describes the things you need to do to terminate your cluster. Otherwise, you will be incurring some charges that you don't need. So let's go back to here. It's now running the second job. It's downloaded. I think it's it will wait for it to finish all the job before it downloads all the docking results. Once it's done, it's back to analyze results page where you can analyze results. This concludes this tutorial. Thank you very much for watching.